Welcome back. This is Neil with Efficient Automation, and here's part number 2, adding a cooling PID to control a chill water valve on the Honeywell WEBS system. So we already have our discharge air temp sensor point brought in. Then we're going to bring in a PID, and we're going to label this CLG for cooling. So that way we know this PID is configured for cooling. Then I'm going to remove a couple pin slots. We don't use deadband delay or deadband. We use just for HVAC, throttle and range, and integral time are the only ones that you really need to be concerned about, because it's not process controls. So we don't necessarily need to worry about everything being so tight. So right here, we're going to click and link our set point, our sensor. We'll bring this over here and kind of get this out of the way. Move our sensor up. Now we're going to need to create a set point. So what we're going to do is we're going to go back up, grab a network set point. We're going to call this DAT_STPT. Like I said, anybody come up with your own names, but make sure you just stay pretty consistent on what you want. So then we're going to right click, configure properties. It's temperature, it's Fahrenheit, 55. Now this is just a standard. You can go in there later on and do a ratio and then change your set point based on outside air temperature to where you have a sliding scale. Now also with something like that, you can also do it in a wire sheet of the points, and you don't have to worry about building it into the controller, just in case your network, you're bringing in the outside air temp via a network point, because then you're going to have issues if it loses communication. So now we have, right here we have our PID cooling with our set point and our sensor. Now we're going to need to disable. So meaning that when it's unoccupied, we want the PID to be disabled. Now there's multiple ways to do this. First, we're going to bring in an OR block and change the name to not. I'm going to go here to my pin slots, get rid of all these pins. So for this one, the way I like to normally do it is we're going to do it based on fan status. So what we'll do is we'll create a binary input. We're going to call this fan status. So whenever the unit sees fan status, or whenever the PID starts seeing fan status, what's going to happen is it's going to throw out a true into here. But then what we need to do is negate that output to where when it's true, it goes to a 0. So we're going to go all the way down to output. We're going to do property negate. So meaning no matter what, as long as it's getting, anytime it's getting a true command into here, it's going to throw out a 0. So that way what's happening is the PID is enabled. There's two different ways. There's several different ways to do this. Like I said, I prefer to do where we do it based on fan status. You can also do it where it's seeing an occupancy command also. It just really just depends on what you guys are wanting to do with the program. Now we have to create our throttle and range and our integral time. So that's going to be a network set point. We're going to call this THR_CLG. So you're going to take this point, configure properties, unit list. We're going to leave this one valve float. For chill water valves, we like to start off around an 8. You can kind of play around with it when you go through commissioning, but we always start off with an 8. When it comes to VFDs and things like that, we'll go to 1.5, 1.2, and then tinker with it to get it commissioned properly. We're going to duplicate this one. We're going to call this one INTG. Go into here to this, configure these properties. And we're going to make this time. And then change it to seconds. And it will start off around 150 to 200. And the PIDs usually come out pretty clean on something like this. So the one thing with Honeywell, the output is where it's going to become an issue. So right now, our PID, I want to show you guys, going to configure properties. We're going to go out to our output. Our action, which is our output, is direct acting. If we wanted to make this a PID for heating or for VFDs, meaning as the reading comes in higher, it starts to back off. Where with cooling, as the temperature increases, the output increases. And then as the temperature gets down the set point, obviously it decreases. So with Honeywell though, or for this program, when the output comes out, it'll be a negative 200 to a positive 200. So an easier way to show 0 to 100 is you go to your math folder, you grab a limit block, put this limit block here, right click, configure properties, high limit, we're going to make it a constant. You can actually make it a block to where if you're doing some additional logic, you can write to the high limit and low limit to affect it however you want. So then we're on low limit, we're going to make that a constant. We're going to keep that at 0. Now we're going to take our output, go into our X, which is our input. Then our output's going to come here. So now we need to create a modulating output. We're going to call this CHWV for chill water valve. And you can do signal for naming purposes. So now we're going to take this output, we're going to go into the input. Since we have BLEMO valves and actuators, we're going to go configure properties, and at 0 we're going to make this a 2. So when it's getting 2 volts, it'll go to 0, and then as it needs to open fully, it'll go to 10 volts. Click OK, and there you go. There's your basic chill water valve PID. Part 3, we're going to do a VFD. So stay tuned.